Yes, yeah, we went through what we were going to do and not do. Okay. So we're going to do 9-6 today. Again, we're going out of order. This does kind of fit in with what we've been doing, so I get why this order was the one that we chose. We're going to talk about how to solve rational equations. There are different ways to solve rational equations. As a true only child, I'm going to show you my way because that's where we live. So, step number 1, and I'm going to say this in Miss Vessel language. I'm sure there's a different way to say it. I'm sure if you look in your book, there's different wording. But I'm going to say it in my lingo. Here we go. Step 1, you're going to look at your equation, and specifically you're going to look at the denominators. And you're going to multiply by anything you see in the denominator. And we'll do an example so you can see what I mean by that. So multiply the entire equation by anything you see in the denominator. At that point, if you've multiplied by the denominator all the things that are in it, it should cancel out the fact that you have fractions. So once you do step 1, you should find you have no fractions remaining. Okay, so step 2 is going to be to solve the equation. There are 2 situations that you could find yourself in. You may have a linear equation, or you may have a quadratic equation. Okay, it just kind of depends on what boils out of the multiplication. So it'll be one or it'll be the other. So for linear equations, remember that we isolate the variable. So if you have a linear equation where you're trying to solve for x or y or whatever variable it is, our process is to then isolate the variable. Isolate means get all alone, right? Get it all by itself. For a quadratic equation, we want everything on the same side set equal to 0. So get everything on the same side and have it set equal to 0. From here, we have choices with quadratic equations. Do you remember one of the choices that I could use to solve? What's a choice? Quadratic formula is a choice. So from here, I could use the quadratic formula. I'm going to call it QF for short. So we could use quadratic formula. And remember, opposite of b, plus minus, square root, b squared minus 4ac all over 2a. Could we also factor and solve? Yeah. So this is almost like a flow chart at this point, right? So you're going to multiply by everything in the denominator. At that point, it's going to be a linear or a quadratic equation, which we've dealt with before this year. Linear, we isolate the variable, right? Get the variable alone. Quadratic, we get everything on the same side set equal to 0, and then we have our choices. We can use quadratic formula, or we can factor and solve. Our last step is to take your answer, or answers. You'll get 2 answers if it's quadratic. And you need to check that your answer does not make the denominator 0. You ran out of room. So you need to double check your answer. Do you remember me saying this word to you before, this extraneous roots word? So extraneous roots are when you do everything correct. All your math is correct, all your steps are correct, your process is correct, all the things. So fast. You can even see it coming through. Okay. So it's when you do all the steps correct, and then when you plug your answer in, it doesn't actually work. So that's what an extraneous solution is. So everything you did was correct. It's not a solution because you did something wrong. It's not a solution because when you plug it back in, the only thing that could have possibly worked doesn't. And in particular, the issue is going to be if it makes the denominator 0. So that's what we have to check in. So once we get a solution, that's how we're going to check it. All right, ready? Okay. So these take a lot of kind of explanation on the front end. I don't know if I'm going to do all 6 of my examples, but we're going to do at least a good chunk of them. You only have 6 of these for homework because, again, I'd rather have you do a good job at a couple than do not a great job at a lot. Does that make sense? So we only have 6 of these for homework, and we are going to take a second day on it tomorrow. So we'll try to get as much of this as we can, and then we will continue on with the same. All right, let's look at number 1. So my first step was to look and see what's in the denominator. So it's like a little game of I Spy. What do you spy with your little I that's in the denominator? An X. Anything else? A 1 in the other one? Yep. Good. Okay, so what we're going to do is we're going to multiply everything by X. Remember, when you have an equation and you're multiplying by what's in the denominator, or whatever you want to multiply by, right? Like, you can really multiply by whatever you feel like. I could multiply by 50 if I was in the mood for that. But what we have to remember is that you have to multiply it to everything. So in order to keep your equation balanced and equal, we have to multiply that X to absolutely everything. All right, so let's start with this part. X times X is what? X squared. Okay. This is going to give me, look at what this is going to give me, 18X divided by X. So what happens to the X's? They cancel. So this is just minus 18 because this X and this X cancel each other out. And that was all a part of my big, like, evil plan, right? Mwahaha. I wanted to get rid of the fractions. What happens on this side? 3X. Okay, so a minute ago I told you I'm an only child. I'm going to show you my way, right? Let me tell you the other way. You make all of them into fractions. You get a common denominator. You combine them and solve them. Do you want to do the other way? Probably no, right? So there's a reason I picked this way, and it's because it's the easier of the two. All right, have we encountered something linear or quadratic? Ooh. Quadratic because there's a squared. Squared means quadratic. Just a 1 power means linear. Okay, so in that situation, we said we're going to move everything to the same side. So I'm going to move everything to the same side. So I have x squared minus 3x minus 18 equals 0. And remember, we had choices, so we can pick our favorite choice. We can factor and solve, or we could use the quadratic formula. I'm going to factor and solve because I believe most of these are super nice and they factor out just all sorts of lovely. Okay, this is a trinomial. X times x is x squared. And we have to play our game. What multiplies to negative 18 but adds or subtracts to negative 3? Negative 6 and positive 3, right? So negative 6 times 3 is negative 18. Negative 6 plus 3, negative 3. All right, so now we're here, and we've dealt with these before. What would make this parenthesis 0 if x were what? 6. What would make this parenthesis 0 if x were? Negative 3. Perfect. Now, this is where we go back and we play, let's check on the extraneous root. I'm going to erase my scribblies for a minute because they're not going to help me right now because I've got to check in with my denominator. Okay, I only have one denominator. Agree it was just this x? Okay, so come back to that x. If I put a 6 in there, would it make it a 0? No, make it 6, right? If I put a negative 3 in, would it make it 0? No. So both these solutions are acceptable and are good answers. They're not extraneous. And the reason I know that is because when I tried to plug them back in, they didn't make my denominator 0. So that's all you have to check. So if I had, let's pretend I had to pull out an x first, like there was an x hanging out front, then x equals 0 would have been another solution. And could I plug 0 in? No. Or if my denominator had been something more complicated, like this, 2 would be off limits here, right? So think about your things that would be off limits, and if you get any of those things, then we have to say, no, it's not that one. Yes?
So you can have more than one?
You can.
More than two?
More than 2? We're not going to have more than 2. So you will either, there's only a couple options for us. We will have either no solution, and that would be if our only solution didn't work. You could have one solution or you could have 2 solutions. Those are your 3 choices. There's not anything else that's going to happen. Okay? All right. Let's play the same game with number 2. I spy. What do you spy in the denominator? 3. And? X. Okay. So everybody gets a 3x. So we're multiplying everything through by 3x because that's going to help me get rid of the denominators. Sometimes you need a little extra help on a Wednesday, right? All right. So again, you could also think of it like Oprah. Have we all seen that episode of Oprah where, or probably not the whole episode, but where she's like, you get a car, you get a car. It's the same thing here. You get a 3x. Like everybody gets a 3x. Okay. Look at this part. What do you have that's going to cancel in this one? The 3's cancel. So there go the 3's. So on this side, I just have 10x. Over here, what cancels? The x's cancel. Boom, gone. So when I multiply, what do I have left? 12 plus. Can anything cancel here? No, because there's no denominator. So I have 6x. This one's easier than the last one because, is it linear? Degree 1, degree 1? Yeah, it's linear. This one was quadratic because of the degree 2. So this is an easier equation to solve. What would you do next? Yeah. Go with your instincts of what you would normally do to solve. 4x equals 12. Then what would you do? Divide by 4. X equals 3. Before I box it in, though, I need to check back in with my denominator. So let me erase my scribblies for a second so I can actually see what they were. All right, I have no place to plug it in here. If I plugged it in here, it would just make it 3. So is this number okay? Yeah, it is not off limits. So I'm going to box it in. It's a solution. Now, if I was taking a test or a quiz and I was nervous, like I get an answer and I'm nervous, and that's honestly just my nature in general, could I plug it back in and make sure it made the left and the right side equal to make sure it worked 100%? Yes. Question?
So is it only like a mixed string or something? Like if there's no solution when it's 0?
So the only time we would have no solution is if, yes, if this had worked out to be 0, that wouldn't have worked. So I would have said, oh, the only solution that could have been a solution doesn't work, so no solution.
So, like for the first step, you can take the denominator, you take all the things?
All the things. And let me say it this way, all the unique things. So for example, let's say I had a problem where I had x over 4 equals 3 over x plus, let's say, another, like, 2 over 4. I don't know, something like that. Huh?
Same thing as the next problem.
Oh, yeah. Ooh, look. Oh, okay. Yeah, perfect. Do you see how there's 4's and there's an x? I'm not going to take the 4 twice. So you're going to look for unique things. So what do you see? You see a 4 and an x.
Like a 2 instead of a 4. Would you multiply?
So a 2 instead of a 4, like if this was a 2?
Yeah.
If this were a 2, then I would multiply by 4x because that's going to help everything go away. So it's almost like, in a way, you're thinking about it kind of like a common denominator. You're thinking of something in common that would help all the denominators disappear. We want the fractions to go away so it can turn back into something we know how to solve. Does that make sense? So that's the goal. That's the dream. Okay, so yeah, I did basically write this problem. So look through the next one. What do you spy in the denominator? 4 and x. And again, we're only looking for unique things, so we're not going to do the 4 twice.
Does the negative in front of 7 force?
Doesn't matter. Nope. I'm not even looking at negatives. That's a good question. Am I looking at the signs? Nope, could care less. I only care about what's living down here. I see a 4, I see an x. So that's what I'm going to multiply by. Andrew, you're next on my list. My ninja skills are super fast today, so, I mean, I don't know if you're ready for me. Okay. What cancels here? X. So what do I have left? 24. Perfect. Plus, what cancels here? The 4's go. So I have 5 times x, which is 5x. Equals, what cancels here? The 4's. So I have negative 7x. So this is another nice one. Do you see how I don't have any squares? Yeah, I like that when that happens because that means it's going to be easier for me to solve. What should I do next? Yeah, let's subtract the 5x over. So 24 equals negative 12x. Then what? Divide by negative 12. What is 24 divided by negative 12? Negative 2. All right, before I get wild and box that in, would it make any of my denominators 0? No. So we're good. Box it on in. I may have lied to you. I think we're going to do all the examples. At first I was like, whoa, 6 is kind of a lot, but they're all a little different. Do you know what I mean?
That's okay though, because then.
Yeah, I just want you to be prepared.
Homework will be easier.
Yeah, I want you to be prepared for all the things. Okay. What do you spy with your little I in the denominator?
Same thing.
The same thing. So I'm going to multiply, what is that thing? X minus 2. Now, do you see how the x and the minus 2 are together? So they're a package deal. So the x minus 2, when I multiply by it, is going to be that set of parentheses. It's a packaged deal. So if I multiply this side by x minus 2, what happens? It disappears. So 5x equals. If I multiply this side by x minus 2, what happens? Yeah, we just have 3x plus 4. So they completely go away. So that was lovely. Okay, now what do I do next? Yeah, let's subtract the 3x. So 2x equals 4. Then what? Divide by 2. X equals 2. Okay, before we get wild and box it in, would 2 make my denominator 0?
Yeah.
Oh, right? It would. 2 minus 2 is 0. So can my only solution that could have possibly worked actually do anything for me? No. So nope. And this is a no solution. Okay, so that can happen. So we have encountered one. So do you see why I'm telling you, like, we're going to do all of them? Because they all kind of come out just a little different. All right, flip the page when you're ready. And they get trickier. Next. Okay. Remember, the x minus 8 is a package deal because they're together in a denominator. So I know I need to multiply by an x minus 8. Again, that's package deal.
Why do I have like a different page?
Yeah, she doesn't get the other problems.
No, I do, but they're like on a really weird
Wait,
page.
where did they go?
They're like back here. Like this extra page.
I don't know.
Wait, so do we just ignore the two? What are all these?
Hold on. We're going to talk about the... I don't know. If you want a new notes packet, I don't... Okay. All right. I don't...
Ignore the extra page.
Just ignore it. I would say another option is if you want some Post-it notes, you could like just do it on Post-it notes, you know what I mean, and put them right there so that the proximity is there, whatever you want to do. Okay, do you see how I multiplied by the x minus 8 as a package deal? Yes. What else do I need to multiply by? The 2. Sorry, I was coming back to the 2. There we go. So we're multiplying by the 2. Oh, I don't like how I have this written. I'm going to slide this over a little bit more because it looks very much like x squared. Okay, I didn't like that, sorry. All right, let's go term by term. What cancels? X minus 8, because it's the same thing in top and bottom. So I have this 2, and it needs to get multiplied to both those pieces. So 2 times x is, 2 times 2x, 4x, 2 times negative 5, negative 10. So be careful and make sure you're multiplying everything. So here we had a situation where the 2 had to get distributed to both parts. Okay, come over here. What cancels? The 2's cancel. So I have this x, and again, it needs to get distributed. X times x is x squared. X times negative 8 is negative 8x equals. On the other side, what cancels? The x minus 8. So I have 11 times 2, which is 22. All right. We are back in quadratic land, yes? So we want to move everything to the same side. Yeah. Yeah. We want to move everything to the same side. And we want it set equal to 0. So I'm going to leave this x squared over here. I'm going to combine like terms. 4x minus 8x leaves me with what? Negative 4x. I have a negative 10 over here as well. And I still have my 22 on the other side. Let's move the 22 over. That's going to be my last step, so it's kind of set up how I want it. So I end up with, and I'm going to move over here, x squared minus 4x minus 32 equals 0. All right, so we have choices. Let's factor and solve. Again, if you want to use quadratic formula, you can. X times x is x squared. What two numbers multiply to negative 32, but then add or subtract to negative 1? 8 and what? 8 and 4. So we need 8 and 4, and you said negative 8, right? Okay, so let's double check ourselves. X times x is x squared. Perfect. Negative 8 times 4, negative 32. Perfect. It's the middle term, right? That's always the problem. Negative 8 plus 4 is negative 8 plus 4, negative 4. Perfect. So we're good. All right, what would make this 0 if x were? What would make this 0 if x were? Negative 4. Okay, again, before we get crazy and back stuff in and call it a day, let's check our answers. Would 8 make any of my denominator 0? Yeah, 8 doesn't work. Would negative 4 make any of my denominator 0? No, so that one is a go. The other one got thrown away. Okay? Maybe it got thrown away at Starbucks. Oof. Yes, that's exactly where it is. All right, here we go. This one. Do you see how when you look at it at first glance, we're like, oh no, there's nothing in common? And do we really want to multiply by x minus 4 and x squared minus 16? No. So this one's different from all the rest too, because I'm going to factor the denominator before I think about what's in the denominator. Okay, what would this one factor into? The x squared minus 16? Yeah. So let's start with that. And I'm going to scribble this out so I don't even look at it. Like this set of 2 parentheses is my new denominator friend. Okay, so now look at your denominator. What things do you see?
X minus 4.
Yeah. What else? Yeah, we need an x minus 4 and we need an x plus 4. All right. On the left side, what cancels?
X
Yeah, all the things. Wonderful. So we just have 16. Love it. Okay, on the right, what cancels? The x minus 4 is cancel. Okay, be careful. We've got our 2, and it needs to get distributed to both things. So I've got 2x plus 8. What should I do now? Subtract the 8. So 8 equals 2x. Then what? Divide by 2. X equals 4. Ooh, can x equal 4 though? No. So my only solution that could have been a solution didn't work. So what do I say? No solution. So do you see how there are so many different things that can happen? Like, it's not like one scenario, right? Like this could happen or this could, like we've got lots of different things. And I think that's what makes it kind of tricky is normally we're used to like, I get one solution. That's what I get, right? And now we have options. It could be 2, it could be 1. All right, so you only have 6 problems tonight and you have a good amount of time to start. Again, the reason I do that is because I'd rather have you do a couple and do them well. I do not give credit on this homework assignment if you do not show work. There is no way, like look at how much, look, right? Like there's no way to do these and just be like, I got 5. No, you didn't, right? You looked in the back of the book. So you've got to make sure you show me work. I will not give credit for homework if you don't show me work. 1 to 6, page 501, I'll put my book under the dot cam. But again, I don't buy it if you don't have any work and you're like, it came to me in a dream. 2.5, it's 2.5. I fell asleep and the number floated into my head. No, it didn't.